Okay, hello, everyone, and welcome to AISC Network webinar. So I'm Yong Wei here, the moderator for today's session. This fireside chat is funded by the Royal Academy of Engineering under the Frontiers Champion Award. So today we are going to discuss what is digital twins and can digitization of construction industry give sense in building sustainable cities in cheaper, greener, and shorter time frame. So we have privilege to hear from three panelists who are going to share about the concept of digital twins, the use cases, and how it has been deployed. But before I introduce the panelists, there are several housekeeping items that I would like to highlight. So this session will be recorded and the video will be available in our YouTube channel in a week's time. We also will provide e-certificate to attendees who submit the feedback form that will be made available after the session ends. And if you have any questions, do post in the Q&A box, okay? And I will moderate the questions and address it to the panelists. So without further ado, I would like to introduce our panelists for today. We have Rahul, joining us from Germany. By education, Rahul is a mechanical and civil engineer. By working experience, he is a Rahul. He studied mechanical engineering in India and worked for 10 years as mechanical engineer at multiple construction sites within India. While working, his interest lies towards civil engineering, especially in tunnel construction. Later, he moved to Switzerland to study the design of tunnels. And then he moved to Germany to start working as tunnel designer, but destiny took him towards the software development field for tunnel construction. After working for 6 years as a software engineer, he started his own company in Germany called Digital Twin Technology to revolutionize the construction industry. We also have Gabriel joining us from Norway. He is currently a senior research scientist with Sintaf Manufacturing and also a part-time associate professor with the Department of Industrial Engineering, UIT, the Arctic University of Norway. He received the MSc degree in computer science from the Budapest University of Technology and Economics in 2007 and the PhD degree in production engineering from the Norwegian University of Science in 2013. His research fields are automation, robotics, computer vision, and control theory. We also have Thomas Reynolds joining us from Edinburgh. Tom has been a Chancellor's Fellow at the University of Edinburgh since 2017. His research in timber engineering and structural dynamics has shown the value of sensing the in-situ behavior of structures to better understand the performance of novel structural materials and forms. And he has demonstrated this for modern engineered timber structures, as well as the world's first 3D printed steel footbridge. Tom is a civil engineer by training and a chartered member of the Institution of Civil Engineers. He worked for 5 years in civil and structural engineering consultancy. So, historically, construction industry have been a highly labor and time-intensive process. The industry has fallen behind in digitization, especially in the use of data analytics and also AI. So I do have a question for Rahul. Since you have worked in the field of mechanical and civil engineering for 10 years or more before switching to software development, can you share why you take this journey and how the industry has changed over the years?
Yeah, sure. So I work a mechanical engineer in India for a construction company, and at that time I don't have much knowledge and experience about this software and to understand about how the new technology can help in the construction. And jump to also to the civil side of basically understanding about tunnel design and tunnel construction. While working as a tunnel construction, so I'm not a civil engineer from the starting, so it was difficult for me to understand about specifically about the geology. And there, I realized, okay, the data is coming from the sensors and provide the information on the 2D platform like a graphical model, and you have to be really good geologist to understand all these things. That and This increased my curiosity. Okay, how to use the technology and let a simple tunnel engineer to understand the geology and what is happening under the ground and above the ground. That is what I realized. And over the 10 years, then the software technology can help the engineers to understand better what they are doing, and they do not have to worry about to understand the expert knowledge. And this is what the software is replacing, basically the expert mind to let understand each and everyone on the construction site.
Okay. And how does the digital twin technology change the way of smart city construction? Can you share what the company has been doing in this area?
Surely, yes. So what we are doing is basically creating a. If I may share the presentation right now, if
Yes,
sure, okay.
you may.
Let me do this. Can you see my screen?
Yes,
Okay.
perfect.
So basically, what is a digital twin? So digital twin has many definitions come across different part, and what in our company, what we are calling as a digital twin is the first thing is about the digital model, that there is a physical object and a digital object, and the data flow between them is manual. So there is nothing automatic. Then which was the previous one. Currently, the situation is about digital shadow, that we have a physical object to digital object. The data flow is automatic, but from the digital to physical, still the manual data is there. When both sides from physical to digital bi-directional, the data will flow automatically without any manual interference. That is what we call as a digital twin of infrastructure. So we create a 3D model. We connect the IoT sensors with this 3D model so that IoT sensors and other data sources available and to update the 3D model automatically in real time. This is what we call as a digital twin for the construction industry. But why we need a digital twin in construction industry? This is very simple to say by this video to explain that in order to monitor the real construction site in real time with what is happening, and then able to compare it with basically the concept of as built versus as design. When this is possible in real time, which is right now we are working on our project Ashwin. So when this is possible, that makes the life really easier, because currently the data is coming from the construction side, then you have to update in the BIM model, and then after that you can see what is happening. How this is going to possible is to connect each and every data source from every part of the construction site, and first of all send it to the central database. This is definitely by using the concept of IoT platform, which we are doing within the Ashwin project. Ashwin project is one of our European Commission funded project under the flag of Horizon 2020, which has been started last year. And we have approximately 12 partners we are from the different areas. What is digital twin for infrastructure life cycle? So we are not talking only in this project about a digital twin from the construction phase, but also from the design and operation phase. Because until unless we don't combine all the full life cycle of infrastructure, there is no point. There are different software available from a different phase, and nothing is connected. So everyone is like in their own world. And within this project, we are happening that we like to connect all these three phases of the infrastructure so that it can be monitored, it can be constructed in the future, and designed in a better way. But with the real-time digital twin, we have a challenge. So the challenge what we are facing is, for the first is capture construction progress. So we can capture, yes, via 360-degree cameras or by LiDAR cameras, capturing, but to capture and then to analyze this 3D capture video and images and point cloud, that is the biggest challenge. not in the offline, but in real time. So in real time, that comes a big challenge, that how to capture it, analyze it, then dissimulate into four dimension, and then render this graphics onto the platform, for which we are using right now the game engine, because we realize the video game engine is very much easy to render the graphics in real time. Still using not such a big point cloud, but with small point clouds, it is possible to render in real time. Within the Ashwin project, as I mentioned, we have 12 partners. Technical University Berlin is leading as a coordinator. And we have industry partners, research partners, and also Austrian standards to look for the standards for the digital twin, because right now in the construction industry, all the standards are basically based on BIM, not for the digital twin. So there is a difference. So this is what we are also understanding, how to create or make new standards possibly to within the digital twin format. In Ashwin project, what we are doing is creating some tools. So basically, evidence-based design support tool, generative design modeler to support design for productivity, construction site simulator for early design phases, construction monitoring tool with productivity safety, simulation-based real-time construction site and logistic planning. Multiphysics model, this one is very interesting tool actually. Multiphysics model matching tool for status assessment of bridges and buildings, which makes this makes possible to use the tools like Grasshopper and connect it with the digital twin in real time. Risk-based status assessment tool, GIS integrator for digital twin based asset management, privacy ensuring safety management simulation and training tool, a configuration management tool to track as designed and as built, as well as to allow seamless commissioning. So this is about the digital twin, what we are doing. Now the point comes the AI in construction industry. So digital twin will not work very good until unless we utilize the artificial intelligence technology also. So AI, how we are going, this is the concept for what we are doing within the digital twin technology, which will be the after our Ashwin project, for better AI for better design of buildings through generative design. We are also working on artificial neural network to predict cost overruns based on factors such as project size, contract type, and competence level of project managers. This is right now we are doing only in the tunnel construction, not in the building construction per se. The AI and machine learning solutions to monitor and prioritize risk on the job site, so the project team can focus on their limited time resources on the biggest risk factors. Then AI for construction safety, like using the image processing to understand if everyone is wearing the right gadgets on the site, if any object is in between the movement of the equipment or the man is there or not. And AI for post construction. So to basically when we have to monitor the infrastructure at that time, to use the artificial intelligence to understand what is happening and if there is any predictive maintenance required. For this, what we did also within the digital twin technology to develop a virtual meeting room like what we are doing in this WebEx, but using the VR headset very specifically to uh, uh, sorry, very specifically to use this virtual reality headset to collaborate geographically or in real time into the construction site using the BIM model. So the building which you are seeing in this image is basically a BIM model of a building, and the three people are in three different locations, and we can um, monitor or inspect the each and every element of the construction industry of the construction site. So what in the future then comes what after this of using the artificial intelligence for the building monitoring and everything, but also we are working, which is our in the pipeline, how we are going to use the complete construction site as an automated. So this is the video which I like to play here, which we are envisioning how the construction site of the future, maybe in 20 years, not so nearly, but can be possible for that completely done by robots, and using the concept of neural network. And for this Currently, we are working on preparing AI on chip, basically developing a processor, going to the hardware development now to create a processor which can be utilized inside of as a brain of construction equipment and can be fully automated, not only for the movement but also to do the all construction work like this excavator is doing. So feed the excavator with the complete plan that how much he has to excavate, and the dumper will understand when to move. So all these movement has to be done in real time without the internet connection, everything within the range, without using the internet connection. That is what our future plan to go for. So thank you very much.
Thanks, Rahul. Wow, that's a very interesting project that you shared. We can see that how the digital replica of the physical entity can actually aid the construction projects and accelerate and also automate whatever traditional design, production, or operational process. Yeah, so and to provide a better efficiency. So yeah, thanks. Really interesting things. Yeah. So I want to go to Gabriel. Since you also coordinated some of the projects before, can you share the solutions that you're building in terms of 3D based BIM model building information modeling systems?
Yes, sure. It's very nice that I can kind of follow the tracks that what Rahul already kind of laid for the project, because I'm the coordinator for we can call it sister project in the same kind of era in this Horizon 2020 framework. And as you have heard also my background, it is indeed followed by computer science. And then we kind of approach the whole problem of how to build a digital twin, digital shadow, or digital thread from automation point of view. So I'm working mostly with robots in factories, but we do have an experience from there and how to kind of approach automation questions, how to apply those things that we could achieve in a factory where everything is very static, everything has its very organized place, to kind of make this construction site that looks like in many cases very chaotic, and to create an order with the help of digital twin. But this is, I think, some slides could help on this sense. So let me just share my screen here. I hope you will be able to see it. Now I can move this out. You can see my screen, isn't it?
Yes.
Yeah, perfect. So the project that I'm coordinating, and this is a sister to Ashwin, it is called BIMprove. It's an improving building information modeling by real-time tracing of construction processes. So we are approaching the same kind of a question of how to create a digital twin on the construction site. And we are solely focusing on the construction process itself. For sure, we would like to include the design and also the demolition phase, so the whole life cycle, but we are not able to do that right now. So we are mainly focusing only on the construction part. There is a lot of information here presented, mainly about the background. So we would like to create a digital twin, which is the expansion of the BIM modeling. So we're using the extended building information modeling to create a digital twin, which is fed by any kind of a sensory information that is coming either from robots, coming from smart equipment, coming from humans, coming from laser scans, and so on. So very similar to what Rahul already said, we would like to create a digital representation, a digital shadow of the whole construction site, and able to provide additional services that we are kind of capable of creating digital services out of the kind of the static construction site we had so far. We have a consortium, similar setup in Europe, as also Rahul said. So we have 12 partners from 5 different countries, from research sector to end users, very high profile construction end users like HRS, ALF Group, and NVIAS. So they will be our kind of demonstrators at the end that whatever technology and solutions are developed throughout the project, we will be able to kind of show it to the public that, okay, this is something that you can use and this is how the digital twin looks like. And we have also the DIN, the German Standardization Institute with us in order to kind of lay the foundation for the long-term use of the results in, for example, a standard form. We are not sure if we will be able to manage it in the kind of the 3 years of the project lifetime, but we are hoping to get at least the first steps there. And how we represent the digital twin and how we kind of envision the twin for us ourselves. This is a little bit more from software point of view presented to you now. So what we say that in order to create a twin, so we have to create a kind of processes that feed the system that we call on the left side, those are the inputs. And also we need a kind of an information presentation possibilities that are called outputs on the right side. And all kind of analysis, artificial intelligence use, and all these kind of analytics, cost functions, and so on, those need to be in the center whenever we have created a twin. So then we can use the kind of information available in a digital form to provide analytics on cost, safety, and for example, also time-wise. So that is what is our vision, and we have already made some small steps in this sense. So we start with the inputs. Let us go from there. So we would like to use drones, robots, in order to make a kind of a geometrical survey of the site today. That what was the progress from the day before. Compare it to the expected progress from coming from the BIM model, and then in addition also what you can see on the lower right button or lower right part, it is something that we call context-related information. So we are in an anonymous way, we are following people on the construction site, so we know that they have been, for example, in a given room, and that we are storing this information that if a work needs to be done in a given room, then we are also know that people were there, so we know that there should be an expected outcome from there. So we are trying to kind of make a prognosis based on if there was people in a given site of the construction. If you were there, then you should have done kind of a work, and then on the next one it will be for the given day, we will see that, okay, if the effect was there or if the wall was built or not. So this is the kind of the inputs for the digital twin. Of course, historical construction data, experience from previous projects, it's very important, and we are also working on that to integrate and to create a better prognosis for our twin to how much time, how much cost will it be in order to create, for example, a wall. We do have a few initial results here. So we have our robot. This is developed by our Spanish partner, Robotnik. So we have an autonomous robot going around the construction site and making a kind of a digital shadow, as Rahul said, from the site itself. So it is an autonomous robot equipped with a laser scanner who is making a point cloud scan from the construction site autonomously. And we already have our very first drone that are able to create a map and kind of mapping the progress itself autonomously. So you can create a kind of, we call that this kind of a recording mission. So we can say that, okay, what part of the construction site you would like to record and what kind of the part of the wall you are interested in, and then you can kind of automatically send in the drone or the ground mobile robot to create a recording from the site itself. So these are the very first steps in order to kind of digitalize the construction site. And these are the very first results we got so far. So a kind of automatic mapping of the geometrical progress is already there. Then about, oops, this one should not be like this. 1 second. So what we can say about, because so far was the inputs were presented, but how do you communicate back the twin to the human user? And I think this also was shown in the Ashwin project proposal, that it is you should have a different medium to different kinds of stakeholders on the construction site. So if you have construction workers who are doing their everyday work there, they don't need most likely a tablet, but they need a kind of a smartwatch or a kind of a communication channel for them to actually very easily interact and to convey information to them, and also that they could kind of communicate back the information back to the digital twin. So we depending on which stakeholder we are kind of attracting, or we want to discuss that, okay, the twin needs information conveys to this kind of a stakeholder, we kind of establish different kind of communication medium. So we have for the construction workers a specific solution. For the truck drivers who are kind of doing the side, we have something called BIM at vehicle. So there is a kind of information for them that when they should deliver goods. And then we have for construction site managers or foremen that they can use their pads in order to see what is the progress there. And also in addition to that, if you are kind of on the site manager side, then you should also meet to discuss and collaborate and to visualize how is the progress today, how will the progress the day after, and also communicate issues. So then we have a solution that is called BIM at Site Office, and something else that is called BIM at Site Office. And what we did so far is that we created the very first kind of result on the construction side, and that is also available on the YouTube channel of the project itself. So there you can see two solutions. One solution is using Microsoft HoloLens kind of solution there, where you can turn on off the BIM model information on the construction site. So where are the electrical sockets and so on. So this is a kind of an augmented reality solution where you are able to see that what was the plan and what should be there and where it should be, and also you are able to actually highlight issues that are coming up, and you can show that, okay, this is not where it should be. You are able to measure distances, offsets, and also where it is. So it is a user mostly adapted to the site manager or the site survey personnel, that, okay, this is correctly placed, this is not correctly placed. You are also able to create kind of a check marks that, okay, this is proper, and then this information is saved in the digital twin for later use. So you can actually confirm that this was done and this was approved by the given personnel, and you can follow back and trace it back if that actually is not as it should be. So that's about the kind of the first user interface for the site managers. And this, of course, also exists in a tablet mode, not that kind of augmented reality version. So you cannot really feel that you are part of it, but it's a very useful tool if you are on the construction side and you want to check out that, okay, what's the difference, where it is, what you should do, and so on. Yeah, so that's the part for the outputs. And then about analytics, and maybe the most relevant part with the AI part. So when we have created this kind of a digital shadow, that we collect all the information from the sensors, from the users, and all the geometry kind of recording of the construction site, then we can provide people different kind of additional services, such as time estimation, cost estimation, and safety checks. And this is what we are working on, and this is not yet available in the project, but this is something that is under establishment. So these will be, we call them these processes, but these are most of the tools here are building on the wide database that is the gathering of all the information from the construction site and the use of that information. The twin, in our case, it is a rolling time window. We can say it like that. So we record every personnel, every robot who is in the construction site, and you can kind of spool back and forth like in the YouTube to see what is happening on the construction site in every second that is happening on the site itself. So we can see the actual progress with this rolling time window. And if you would like to kind of connect this rolling time window into kind of the formal way how the construction sector is working today in a contractual way, well, this is visualized here. So we start from a kind of a common truth that, okay, this is the BIM model of the construction site we would like to build, and the digital twin is a kind of a copy of that. So the twin in the very first day when the construction starts, these are totally equal. And then when we get, for example, a design update from the client, then you also merge this information to the twin in a very formal way. Everything is traceable, so everyone has to approve that the change has been happening and the change has been done. And then also when we do a kind of an automated check by robots, so we do a check, a comparison between as designed and as built. So then we get a kind of work from a computer science perspective. So we actually create an issue that, okay, that there is a change according to the plan, and then this needs to be approved. And the approval rate is of course slower in the original setup of the construction sector. So whenever there is a change from the original to the kind of a deviation, then we need to get an approval from the client, and this is way slower than the kind of the update of the digital twin. So this is what is visualized here. So when you get a difference in the as-built, then we also kind of notify the client that there is a deviation, so the wall is not there and you need to change something. So then it is also convinced to the client that, okay, please approve this change, that this change is then according to your specification. So this is what is kind of visualized here, that every change either from the client side or from the construction side is approved by the client at the end. And with this we can ensure that the contractual part of the construction is still ongoing. And we will demonstrate this twin, the use of the twin in 3 different places, one in Switzerland, one in Spain, and one in Norway. All of them have a little bit of a different kind of focus. So in the case of on Switzerland, at pilot use case there, we will be focusing on fire protection. Fire doesn't occur that so often on the construction site, but when it occurs, it has a major impact. So we will try to avoid that kind of fire in the construction site. In Spain, we will be focusing on fall protection. It will be a focus on uncovered regions where usually people can fall through, like shafts or elevator shafts, I mean. So this will be trying to use that as a case for us. And in Norway, we'll be using normal digital twin, only solely focusing on the cost and the time question there. Some pictures of our pilot use cases. So in Switzerland, in Bernier, there will be the construction site used as there, and we have a kind of a place where they build parking slots, parking garages, and we will try to, because there is welding going on in the construction site, so this is where we would like to kind of prevent fire occurring in the process itself, or detect hazardous fire hazardous events. In Spain, there is a kind of a rebuild and expanding of an additional building in Madrid, Spain, where there are parts that will be kind of cut holes in the slabs of the different floors, and this is where we would like to kind of highlight that to prevent falling happening on the construction site with the use of digital twin technology. And then last but not least, we have also a site in Norway. It is in Oslo, and the main city of Norway. There are residential houses will be built, and this is where we would like to kind of highlight that the use of digital twin will give you a spare of 20% of cost and time related to classical construction processes. So that's what is what's the project about, and you can read about how we see for digital twins and data integration in the ISO sector here in this white paper, which is free to download, and you can also read more about the project on the BIMprove Horizon 2020.eu. So thank you for your attention, and open for discussion later on. Yeah.
Thanks, Gabor. Yeah, it's a very good use case that you presented just now. So before we move to Tom, there is a question, although Rahul, you already answered that in the chat, but maybe if you want to add on anything, the question is there any role connector between the BIM model and FM model? Maybe for Rahul and also for Gabor, any one of you wants to add on?
So yeah, in the Ashwin project, we are working for this thing. So to connect with the FM model to the BIM model. So currently, we have done using the grasshopper. So some results we are taking from the grasshopper and then simulate that result into the digital twin platform to the real time. But right now it is in a beta model, so still working on. So to make in the real time, it will still take time. I'm hoping it by the end of this year we can able to do this thing in real time and to present it to the project. So this is the goal of Ashwin, to make the connection between the finite element modeling and to the digital twin. So in this way, yeah.
Okay, thanks, Rahul. Gabor, anything you want to add on for this question?
Yeah, it was maybe back to the question, the FM models, wasn't it that one meant to be the facility management? So I think so it's of course a very important step from how the construction model looks like to the facility management, and I think we need to add a really huge amount of information there for the in order to provide the necessary and good quality BIM model for the facility management part. So it is there is no one-to-one map, because the facility management, they need way more information that is, for example, needed for the construction sector. So yeah, it could be used, but it's not yet there. Yeah.
Okay, thanks. Okay, so we are going to move to Tom. You are involved in the creation of world's first 3D printed steel pedestrian bridge. So can you share how it was conceived and how you use statistical techniques to test the behavior of the materials and how the structure works? I know you won an award for this.
So I think, yeah, shall I open my presentation and
Yes, sure.
talk from there? So I think it's probably important to say that probably my role in creating the sorry, let me just switch displays. There we go. My role in creating the bridge was quite limited, but what I've really been involved in is developing the sensor network and how we use that sensor network to understand how the bridge performs. But I'll be yeah, what I'll do, because this 3D printed steel bridge is such a fantastic structure, I'll take you a little through. If we can cope with my display swapping around by this software, I'll take you through a bit of the background of how it was developed using some of MX3D, the company that created it, some of their visualizations. I think so. Well, let's see how we go. The software doesn't seem to. So are you seeing a swap back and forth between the two screens?
Yes.
We'll work with that as best we can. And can you see yourself on the screen now?
Yeah. Now it's okay already.
It's okay. Great. All right. Fantastic. So just to explain my involvement in the project, I'm an academic at the University of Edinburgh. And the University of Edinburgh is a partner in the Alan Turing Institute, which is the UK's Institute for Data Science and Artificial Intelligence. And they partnered with a company called MX3D. They companied with a company called MX3D, who created this this incredible footbridge. I think even before you know anything about the construction process for it, it's quite a striking structure, and even more so given the way that it was built. This is the bridge at the as an exhibition at Dutch Design Week, which is a in the Netherlands, an exhibition of kind of cutting edge design. We're actually talking on the day that this bridge is being opened in its location across the canal in Amsterdam. So it is now a kind of or it will be today a fully operational footbridge. And in contrast to what Rahul and Gabor have been talking about for the most part in their talks, the focus of our digital twin is on the operational behavior of the bridge, is on the operational structural behavior, and on how it's used by people. So this video describes the development of the bridge. Let me just do it for YouTube. So the bridge is 3D printed with wire arc additive manufacturing. So it's almost like a continuous well of stainless steel, which enabled MX3D to create this continuous, quite organic shape of the bridge, which would have been very difficult with conventional steel processing. It's now in place over the bridge there, over the canal in Amsterdam, and what's next, I suppose, following on from that bridge is this. So again, it was notable with seeing Rahul and Gabor's presentations, the kind of the large teams, the large consortiums of partners that are required to kind of really understand these projects and work towards digital twins. And so what's happening now is our consortium is working with the sensor network on the bridge and trying to get the inputs that we will need to eventually develop a digital twin. So I'm not going to be able to show you 3D models of kind of completed digital twins of the structure, but what I'll be able to talk you through is how we're working towards that, by understanding what information that we can get from different types of sensors on the structure. So there are quite a lot of structures out there, bridge structures particularly, which have quite a lot of structural sensors on them. I think probably the MX3D bridge is quite stands out for the variety of different sensors that are there and the kind of different things that we can find out, and that's going to enable us to look in detail at different aspects of the bridge's behavior and think forward to different implementations of these kind of systems in the future and what we might need for those. So there's a list of sensors in the sensor network down the side of the image there, and a map of how they fit onto that organic shape of the bridge. The pictures at the bottom of the screen for me are a real indication of how much we look forward to wireless sensor technology and being able to do these networks wirelessly. The cabling for a kind of major sensor network on a relatively small bridge is so difficult to cope with channeling around the structure, and you can see a bit of what you end up having to do with kind of controlling those cables and fitting them all in. So with the sensor network, we I think there are three very broad aims of what our group is trying to do, what our team is trying to do overall. And my personal involvement is just in one of those, and I'll get into that. So I suppose the first key aim is that this 3D printed stainless steel is a new structural material for a structure of this size. And so having a sensor network, building a digital twin, is an opportunity for us to really accelerate the understanding of the in-situ behavior of a structural material. The construction industry is so dominated by steel and reinforced concrete and perhaps timber to a certain extent. If we are going to change the way we build, address the climate crisis, and all the other environmental impacts of the construction materials we use, we're going to need to be able to understand new materials more quickly. And so that's one of the things we're trying to do here. But we will also be able to, so Amsterdam sells itself as a smart city, and this bridge is a chance for us to understand and communicate to the city the usage of the bridge, and you know, who's using it in what way, and at what times. And then thirdly, as I say, there's quite a diverse sensor network on this structure. So by understanding this diverse range of sensors, we can consider how other structures in the future might be more minimally instrumented to still get good information. So one of the really fascinating types of sensing that we've got on the structure is driven by our partners at Autodesk, who are really kind of leading the software side of implementing the sensor network. And they have this system for taking videos of the bridge and anonymizing the people who are using it. So turning the video images into these colored kind of skeletons of people moving across, so that we can have anonymized data on the way the bridge is being used that can be then more ethically used by governments. In my work particularly with my PhD student Zach Gwynn, we're looking at one particular type of sensor on the bridge, which is accelerometers. And here's a set of accelerometer data from the bridge, and you'll see that it's kind of fairly unintuitive in itself. We can see some increases in usage and reductions. What we do is we turn that into engineering parameters. We turn it into frequency and damping measurements. And we can now see how those wander around, and there are clearly kind of different times and patterns of usage in the bridge. And Zach's real innovation then here is to take those changes in frequency and damping and use them to estimate what the load applied to the structure is. So this bridge sits on load cells, so we know exactly what the overall load is on the structure, and that's this red line on this graph. What we're able to do is use accelerometer measurements. So measurements from a sensor. Accelerometer is much easier to install than putting load cells under the foundations of a structure. You could just stick a series of accelerometers on the side of the structure. And we're finding that by looking at those changes in frequency, we're able to map fairly well the changes in load on a structure. And this is the kind of information that for a structural engineer, for a use stage digital twin of a bridge, is absolutely key information. How well do those loads that the designer assumed at the design stage compare to the real usage, and what needs to be updated in that sense? As we move on towards a digital twin, we're starting to look at how our measurements compare with finite element model by partners at Imperial College London, led by Leroy Gardner and Craig Buchanan. And as we go on, it's a large team that's involved in the project. So I'm just putting up this slide so you can see all the partners who will eventually be involved in developing that digital twin, whatever form it finally has. And there's me and my contact details if any of you would like to get in touch with me afterwards.
Okay, thanks, Tom. So, yeah, you were working with a lot of sensors, and those data from the sensors are important for creation of digital twins. So, is there any standards process or verification in place to help to filter out data that maybe are not good or unnecessary?
So that's certainly something that we're building up and working on. Let me stop my so is that okay? There's a little bit of background noise there. I'm just going to stop sharing my screen. So yeah, so data verification and dealing with when sensors drop out and where we get unusual values from them. So one of our kind of key strategies in that area is having a sensor network that has redundancy to it. So although it's installation day now and we're just starting to get sensor data back from the bridge live, we do have data from commissioning tests that were carried out at the University of Twente with partners there. So what we're seeing is that by having redundancy in the sensor network, we're seeing that for some sensors, when we lose data, we're able to sufficiently well either predict what that sensor would have read based on readings from other sensors, based on using machine learning methods there, or to adequately, be working with higher level data like overall estimates of natural frequency or load, for example, which can still be estimated even if we lose individual sensors. But having said that, there are some sensors which we really struggle if we don't have them. So there are some really critical ones that it comes more down to a job of physically trying to protect them as best we can. I think we seem to have a bit of trouble with Young Wei's connection.
Sorry, can you hear me now?
Yeah, I can hear you again now.
Yes.
Yeah.
Okay. Yeah, we do have questions from the participants. There's a BIM practitioner asking if there is any suggestion or good resource to get started with AI or ML. Yeah, because AI, ML, it can be complex and challenging, especially for developers or practitioners or consultants who are new in digital twin concept. So, any suggestion? So,
I think my suggestion, hopefully this is a constructive suggestion. I would say to get started with AI and machine learning, it's great to talk to an expert. There's lots of information out there, and lots of software packages which would kind of suggest that you could get in as an engineer, as a kind of highly kind of qualified technical person, that would suggest you could dive into applying machine learning and AI methods. The best thing that I've had in my career in terms of moving into that field is having a really good partner in our School of Informatics here at the University of Edinburgh, who has been able to kind of support me and my PhD student in kind of getting into AI and machine learning. So, universities are always open and wanting to collaborate with industry, and so I would say an expert partner in that field is a valuable thing.
Okay, thanks, Tom.
Right.
Rahul, you want to add on?
Yes. Yes, no, I just want to add that Tom is very right, because for doing anything in the artificial intelligence or machine learning, you need an expert, which I have seen in my working here, especially in the construction industry. When I was working for a company, and I asked, okay, we need a data scientist for understanding the patterns, and we can make a prediction. And even the experts who are experts into the civil industry for 25 years, they simply say, so data scientists cannot understand what is happening in a construction site. So that is the myth which the construction people have to take out of from their mind. It is a data scientist is not going to understand what is happening in the construction site. Data scientist is going to understand the pattern of a data which is available, and then they will tell you what is happening. Then you can make a prediction, okay, how to do that. So definitely you need an expert data scientist for your machine learning algorithm development.
Okay, thanks. Giver?
Yeah, I just can supply that it's, yeah, you need an expert partner, and the domain knowledge is very important, as also Rahul said. So it's don't try. So even though you are an expert in somewhere else, you might fail in the construction part. Yeah, that's all.
Okay, thanks. So we have a question for Greg Bamber. Who is asking the panelists to comment the implication for workers of the advent of AI in construction industries. Well, basically, we know construction industry is highly laborious, so what is the impact? A lot of people have this concern. Will
Surely.
it replace the human?
No, so if I make answer, so I read the question earlier also. So it is not going to replace human beings of the jobs of the human beings, and we have seen that this is not new. We have seen when the computers were coming in 80s and 90s, and the whole world was, oh, the jobs are taken away from the human. Computers did not take away our jobs. They in fact created more jobs for us. So computers are doing the things which is on a, so in a construction site, the artificial intelligence will tell us how to do the productive job. They are not going to do our job. They are just going to tell us how to do the things productively. So it is not going to replace human being. It is just going to replace the for example, in the robots in the construction site, it will replace a human being when the job is very dangerous for health wise. So why not? And let the human being do the other thing, maintaining of the machine, and do the job which is not dangerous for life. For example, in a construction, tunnel construction, it's very difficult. Sometimes it's very dangerous to go inside of the tunnel because of gas and because of other reasons. And let the robot can do so. Why we have to face the human life in that case?
Okay, thanks, Rahul. The other panelists, Tom, you want to add on?
Muted.
You're muted. Or maybe.
Sorry, I would, yeah, no, I would heartily agree, Rahul. I think we may have to be ready to do different jobs, and and I hope that those will be more highly skilled and less dangerous jobs. But I think we're certainly not seeing a kind of reduction in the kind of requirements for the labour market yet.
Right, right.
Okay, thanks, Tom. Okay, Gabriel?
Yeah, it's I think especially AI in construction site, it has two sides. So first implication is on the workers, whether they lose the job. I totally agree with Rahul on that. That's not really gonna happen. But I think the other side of the AI is the analysis that you could do, which is to kind of benchmark your employees. And I think that's the dangerous part, where you start kind of exploring the real use of AI to understand that whether this person was effective enough on that construction site on the given day. And I think that's what also the workers will kind of show resistance toward the use of AI in this sense. But this is in general every this kind of supervision of human workers that can be used against the worker. It's an unethical thing, and that should be avoided. But there is still in the use of the AI that's the only warning sign, at least for us right now in the construction site.
Okay, thanks. Yeah, there is another questions to all the panelists. Is digital twin technology applicable to offshore structures or projects?
So if I understand the offshore structure, is it here? He is talking about like in the petroleum industry, in the refinery, petroleum industry, when we have where we dig oil, so that kind of a structure. If he is talking about, then yes, digital twin technology applicable there. In fact, a company Shell, they are already in the movement of creating a complete digital twin model for their oil dig area to make it completely robotic, because it's a very, very dangerous area for a human being to work. So they would like to make it 100% robotic and to be controlled it via virtual reality sitting on the ground, so that if any accident happens, okay, the structure will destroy, but not the human being in that case.
Okay. Yeah, thanks. I hope that answered the questions by Kavi. Okay. Well, yeah, just about time. So thank you very much to all the panelists. We can see that the digital twins are taking construction industry to the next level, and ultimately we can see that hopefully in the future we can democratize the design of the construction field. So just before we end, let me share my screen. I hope there's a feedback form for that. I hope all the participants can fill up. So we will only give out the certificate after we fill in this form. And thank you to the panelists again, and thank you to the attendees. We hope to see you in our next event. So do join us in our social media if you want to reach out to us, or you want to reach out to any of the panelists today. Yeah, so thank you very much. Yeah, so thanks Rahul, Gilbert, and also Tom. Hope to see you guys again.
Surely. Thank you so much.
Thank you.
Thank you
and
so much for that.
touch. Okay.
Thank you for having us.
Definitely. Then have a nice
Thank
time
you.
then. Bye-bye.
Have a nice day.
Bye,
Bye.
everyone.
Bye.